right? Sounds good. Okay, so let's review what we learned from last week. Last week we learned two topics. One is the two more people in the waiting room. Sorry for that. Okay, all right. So last week we focused two topics. One is the greatest common factor, right? Greatest common factor. Everyone easy to understand this one, right? Second one is called group factor. Group factor. Just like when they show up four nominal four terms, we're likely to have group them, try to factor them. So group factor. So our homework actually focuses this one. So we use the homework to review here progress. All right, so first one, find the GCF, greatest common factor. So you can see here easily, right? Easily, first number one, 32, 4 times 8, right? 4 times 8 and 36, 4 times 9. 8 and 9 are prime to each other, right? So the greatest common factor is 4, right? Number two, 36, 90. 36, you can 6 times 6, right? And I'm sorry, you can also get 9 times 4. And here is 10 times 9. So actually can be further, right? Here actually is a 9 is the greatest common factor, but not the greatest, because of here can be rewritten into 18 times 2, and 90 is 18 times 5, right? 2 and 5 at this moment is prime to each other. So the greatest common factor for this one is 18. Here is 4. Let's see number 3. Number 3. So 18, 42, 84. So you can see what's the greatest common factor? 18, 42, 84. So at least if you only see 42, 84, you can see 42 is the greatest common factor, right? So okay, so we can quickly see here, use your mind. 6 times 3, 6 times 7, this is 6 times 14, right? Right? So 3 and 7 is prime to each other already. So 6 is the greatest common factors. Did you guys can got it? All right. Number 4 here. Here we can got is 15 times 2, 15 times 5, right? And 15 times 7, right? You got it? 15 not times 7, 15 times 9 actually. 15 times 2, 15 times 5, 15 times 9. So you can got 15 is the greatest common factor for this one, right? Is it correct, everyone? Correct me, so sometimes I also can make a mistake. All right, so number 5 here. We can quickly see this one, 24, 14, and 21. If you see last two, actually 7 is their greatest common factor, right? But see first two, you can see not easy to see. 24, 14, 21. So you have to find the greatest common factor of these two first, right? So you can say 2 times 12, 2 times 7. Oh no. So this one cannot divide by 2. So 2 is not a greatest common factor, right? Is it correct? So let's break it down a little bit further here. So here is 2 times 3, right? So here only can break it down 2 times. And here is breaking down 3 times 7. So did they find the greatest common factor here? 2 is not, right? 3 is not neither. So only 1 is their greatest common factor, right? Is it correct? 1 is their greatest common factor. They cannot overpass 2, right? 2 is not their greatest common. 3 is neither. Oh. Is it correct, everyone? What's your answer of the greatest common factor of list number 5?
I got the same.
Good. Okay. All right, let's move on next. 6. Here is 15, 25, 27. Let me write down here 15, 25, 27. Here you can only got 3 times 5. Here go 5 times 5. Here you got 3 times 3 times 3, right? 3 is not greatest common factor of them. 5 is not greatest common factor of them. So only one is their greatest common factor, right? So this is based on numbers. You maybe learn this one in pre-algebra part. That's not in our teaching range, but we just review this part. Actually, but before you join this one, you definitely should know this part. So we go a little bit further, like about when they have variables, how it look, find the greatest common factor. So number 7 is a good example here. So here's y squared, y power 4, y power 7. So definitely y squared is their greatest common factor. Easily come out, right? Number 8, x cubic, x squared, x power 5. So x squared. Because just like I say, this is the same one, easily to find the greatest common factor here. So number 9, you easily can find out is j power 7. Number 10, you can see y power 8, right? The least one. If they are the same variable, different exponent, so the minimum one is their greatest common factor. All right, so you can see go 11. So let's 2 variables. So actually, like you can see the same variable part. The greatest common factor for the x part, so it's x, right? For the y part, this y squared, y cubic. So y squared is their greatest common factor. So all put them together. All right, let's see 12. 12, that's P and Q. This is only P and Q. Let's first see P, the minimum one, 7, 8, 9. So it's 7. Q1, Q square, cubic. So only need a Q out of there, right? All right, let's see 13. 13 is combined situation. They have variable, non-variable coefficient. So we see the coefficient part first. Coefficient 14, 12. The greatest common factor is 7. X, this one no X. So there's no X here, right? The greatest common factor, so it's 7. So it's 7. All right, let's go this one. 14. So for the similar coefficient part, the greatest common factor 20, 15. The greatest common factor is 5. This is Y, this is no Y. So of course, yeah, no Y here. So greatest common factor is 5. We go even further, 15, 12, and 20. 12 and 20, 4 times 3, 4 times 5. So 4 is the greatest common factor, right? So y power 4, y power 3. So y cubic. Same for the 16. See 16 here. 32, 18. 32, 18. This is 4 times 8. Oh no, sorry. 32, 18. Here only 2 times 16. 2 times 9. 16 and 9, they are no common. They prime to each other, right? So the greatest common factor is 2 for here. So the rest is x power 5, x power 2. So x squared is the greatest common factor. So up to now, we can find this one we easily out of there. All right, let's move forward. 17. So negative 10, 15. The greatest common factor, actually, we can pull 5 or negative 5, 5, negative 5. So it's fine. Positive, negative. And sometimes people like to add negative more, right? It depends on you. So it's both works, negative and positive. We can use, most of the time we can use the positive. You also can use the negative as well, negative 5 or positive 5. So for the x part, for the variable part, x squared, right? Here is square, here is cubic, so it's square, the minimum one. C18, negative 21, 14. So we can 7 or -7, both works. So x, here is x cubic, here's x. So we just need x here, right? The greatest common factor coming out here. All right, so also go to the 3 terms, finally a greatest common factor. That's a little bit challenging for everyone as well. So 19, the 19 here. So here is 12, -6, 3. Where 3 is the greatest common factor, right? 3, because of 3 here, if you see the first two, -12 and -6, the greatest common factor is -6, right? But as you can see, this -6 and 3 is 3, right? So you cannot take 6 as the greatest common factor. 3 is one of them. What about the Valera part? So Valera part here is power 3, power 4, power 5. So only need the power 3, right? Of course, you also can put negative in front. Negative, positive, both works. All right, see 20. Here's 15, 5, -20. So 5 is the greatest common factor of the coefficient part. And for the Valera part is y square, y power 7, y cubic. So y square, right? All right, let's see 21. 21. So coefficient part, -18, 9, 36. So of course it's 9, or you can say -9, both works. So for the x part, x cubed, x square, x cubic. So x square is the greatest common factor. What about y? Y and y cubic, y. So just need y out of there. Well, this one. What about this one? 22. 22 here is 7, -21 and 14. So 7 or -7, both works for the greatest common factor for the coefficient part. All right. So for the x part, x cubic, x square, x. So of course, just leave the x, right? Y square, y cubic, y square, y power 4. So y square, right? Out of here. All right, see 23. We talk pretty quick. If you have any questions, just stop it for me and let me know what's going on if you don't understand that one. Let's see 23. 23. So for the coefficient part, here is 20, 50. So of course 10 is then, right? 10. Can you guys imagine? Can you get the 10 out of there? And what about a power 6, a power 7, so 6 out of b square, b, c is power 8. There's no c here, so we have no the greatest common factor is 1 for this one. So totally will be 10, a power 6, and b. Let's see 24. 40, 64. What's the greatest common factor? 16, right? No. 8 times 5. Here is 8 times 8, right? So 8 is the greatest common factor for the coefficient part. And x power 7 and y and no z, right? Z here, no z. So no z. So that's for the 3-term part, a little bit challenging. Right? For the rest one, we can find out is you first need to find a greatest common factor for the coefficient, the same variable, and finally a greatest common factor, right? And y and z, something like it, all different variables have their own greatest common factor and combine the product of them. Consider the greatest common factor for the all terms, right? All right, let's move on. Do you guys need to print screen this part? You can print screen first before I change. A little bit busy here. All right, so I will clean it. Let's move on. Second section. Find the greatest common factor for each description polynomials. All right, so the same progress. Let me zoom in a little bit, make it bigger. Right. So see the 25. So actually we consider these two terms, right? So the greatest common factor is 3, right? So rest is a plus 2. So if you distribute inside, you got back here, right? All right, see 26. 26, the greatest common factor for 18, 12 is 6, right? You got 3a plus 2, right? All right, 27. So you got a 15, 2x minus 1, right? If you do distribute, it just actually distribute inside is reverse progress of this great common factor, right? This is 7 and the 6x minus 1. All right. So we go a little bit more challenging, right? Really challenging. So here, 29. So is x squared is the greatest common factor. Here's x plus 5. The rest, right? Just double check it if you are not confident to this progress, all right? So here is y power 4, and rest is y plus 6, right? It's pretty easy, right? We just learn the basic kinds of progress. This one looks like everyone say, oh, this is too easy. Why are we still learning this part? Because in near future, we use this a lot, right? Just continue using this part. 31, see the 31. So here is 2y power 3, and the rest is 3y plus 1. You can check this part if they are still have the great common factor other than 1. If they are still have great common factor other than 1, you need to put the 1 in the front, right? So it means the earlier you put it in front is not a great common factor. Just double check if these two is pointing to each other. If they have the great common factor other than 1, you should be put that in the front in the great common factor part. Right, this is 32. 5, 10, so it's 5x. Here is square, right? So the rest is right. So you can quickly check if you're not confident about the result. All right, see 33. 33 right now you have 3 terms. 4, we quickly can see the 4, 2x sorry, not 2x. Only 1x minus 2y and plus 1, right? And the third, this 7x plus 3y minus 1, right? That's pretty easy for you guys, right? That's no big change. If you still have question, just double check it. All right, see 35. 6, negative 9, 12. So 3 is their greatest common factor. X power 3, power 2, power 1, so x. So you can get a 2x squared. Here is 3x, right? And the last one is plus 4, right? Some people maybe ask me, say, this one can do group factor? I think someone maybe check. We didn't go group factor for this part. Here we just say group GCF for this expression, all right? Actually, sometimes this part can further be factored. So we didn't do that way. 36. So 12, 16, negative 8. So you can say 4, right? For the x is only x1, right? So you can get a 3x squared plus 4x minus 2. All right. So right now it's more and more come out. So here is a for the a part, power 7, power 3, power 2, square. So it's a square. What about b? B power 6, b power 2, b power 5, b power 2. So b squared. The rest, a power 5, b power 4, right? So this part, second one only left a, right? And the third one, left is b cubic. And the last one is negative 1, right? Let's see 38. So x, y, for the x part, 9, 3, 4, 3. So you got 3. What about power 6, 5, 3, 3. So you got 3, right? So the rest, x power 6, y power cubic. And the second one, left is y squared, right? And for third term, you only x left. And the last one is positive 1, right? So definitely they are prime to each other because so this is 1. The greatest common factor for this term definitely will be 1, right? Let's see 39. 39 over 4 right now. So you can see this. See this. So you can see the greatest common factor is what? 4, right? What about x? X. The last one, no x. So should be no x here, right? So here it became 2x power 5. The second one is 4x power 4. And the third one is 5x cubic. And last one is 3. Right? So we can find the greatest common factor, put it in front. All right, let's move on down 40. 40 part. 40 for this one. For this one, let's see here. 9, negative 27, 18, 6. So what's the common factor of them? 3, right? So 3y power 6. Here is 9y power 4. And 6y squared and plus 2. Double check it. Looks like they don't have great common factor, right? Especially for this one and this one, the great common factor is 1. So there's no additional out of there. All right. Anyone have questions to this part? No. So we move on, right? 41. Move on. So here you can quickly see is the coefficient part have some special, right? 1/3. And x is the minimum one for the variable part, right? So you can get x power 3 plus 2x squared minus 4x power 4, right? And the last one is 1. So take this out, the inside described more obviously. So of course you can sequence them first. Also can sequence them. Make the biggest and lowest by the sequence. All right, let's see 42. Here is 1/5 out of there, right? 1/5. And take a 1y. Here is 7, 5, 2, 1. So we just need to add y out of there, right? So the rest here is 2y power 6 minus 4y power 4. And here is 3y. And last one, -2, right? So you can distribute that, you can go back. And 43, you can see this is actually go a little bit further. You can see this is a binomial, they are common. So this part we can take it first. This is the common factor, right? Common factor of this expression and this expression. So the rest is y plus 3. Go a little bit for more. 44. The result here is so y squared plus 1 is their common factor. And the rest x minus 3. Just like a distributed first step, right? You did time here first and time second one. So you got there. Right. So see the 45, the y plus 4 is their common factor, right? And the rest x, no x, is z, right? Z minus 3. And the 46, so x plus 2 is the 1, is the common factor, right? And the rest a minus y. It's too easy for you guys right now, right? Since you know this progress. And this is this have 1 here, right? We don't Don't forget this part. And the last one here, 48, b cubic 5, and here is q plus 1. You still have 1 here. Don't forget it here. Okay. All right. Let me see. Second page. Second page. Find negative number or GCF as a negative coefficient from each polynomial. Just actually find the GCF actually right now is considered as negative coefficient. If they have both negative, we put a negative in front, right? All right, so see this one. 49, -2, so x plus 7, right? So here -7, so y plus 3, right? If you distribute inside, you can easily get it. So here we say negative x power 5 and 2 minus x squared, right? Right? X power 5 is negative x power 5. Here is -2 and 1, so -1 in front. X power 5, 2 minus x squared. Right, so here is negative y cubic and 5 minus y cubic. Right. All right, so see the 53. So here is -6, 9, -3. So you got -3 here. And what about a? I didn't finish a, right? I didn't finish a. So you can say -3a. Here power 4, power 3, and power square. So you just need to take square out. So the rest here is 2a squared minus 3a and plus 1. Right? Is it correct? All right, see 54. 54. So -5. So because of here is 10, -5, so we put -5 here. What about variable m? M here power 6, power 5, and power 3. So we just need power 3 out of where, right? So the rest here, m cubic minus 2m squared, and here is plus 1, right? Plus 1. All right. The relative easy part, right? Relative easy part. Any questions, everyone? Okay, so we move to the group factor. Let's go see here group factor part. This one need by group factor, so it means need to separate, right? Because something like here, if I really give you these two terms together, they don't have a common factor, right? If you see these two terms, they have common factor, but these two have no great common factor. So how to group? How to group? We normally pick at least they, just like these two, they have common factor, and the rest two, they also have common factor, right? So we have, or you can say these two have great common factor, and these two also have great common factor. Both works. Both works. You can pick these two and the rest of these two as another group, or you can first two and second two, right? So you can get here well. So let's do the first one. So is x, first two here, x squared is the common factor, greatest common factor of the first two here, right? So the rest is x plus 2. What about the second part? 5 is the greatest common factor in x plus 2. So you can see x plus 2 right now, it became a great common factor and became a common factor for these two expressions. The rest you can do like this, right? You can take these two out first, and x squared plus 5, so you can get this part. All right, let's go to 56. Similarly, we take first two and second two as the group, and this is group, this second group. So first one is x squared, x plus 4. And second group common factor is 3. The rest is also x plus 3, x plus 4. So x plus 4 is the common factor of these two groups, right? So we can quickly get out of here, right? Same. right? We can first two and second two as a group. So first is 5x plus 3. And second one is y, x plus 3. So x plus 3, x became the common expression, binomial, common binomial. The rest is 5 plus y, right? Same. Do this two group problem. So y, x plus 1. Second one is 2x plus 1, right? So x plus 1 is the common, and the rest one we just need to put to separate. So actually, you guys do the earlier do the FOIL progress. Finally, is here is reverse progress of the FOIL, right? We right now do this progress. So this progress is use the FOIL. You can multiply inside and got this one. Right now we backward, we call reverse FOIL, all right? Reverse FOIL actually is group factoring progress. All right, let's see 59. First two, second two, all right? So you can say 2x squared is the greatest common factor of the first two terms. And the minus 2, right? And second one is 5, 3x minus 2. So 3x minus 2 is the common part. And the rest is 2x squared plus 5. Right? Much easy, much easier. No challenge for you guys, right? Did you guys feel a challenge here? I didn't hear anyone get a response.
No.
Too easy, right?
Not really.
Not really? Yeah, okay. Which part?
Right.
Okay, let's do more practice. That's why we need to practice, make you familiar with these kinds of progress. So first two, 16, 28. So what's the common factor? 4, right? X squared part, right? So the rest is 4x minus 7. See the second part. Second part, 12, 21. The 3 is the common factor, right? It's 4x minus 7 as well. So 4x minus 7 take first out, and the rest, right? I'm writing is not so good. Sorry for that one. All right, 61. First two, second two, 5, 6, 5, 6. Looks like pattern here, right? So first, m is the only one common factor here. So 5m squared plus 6n. Second part is 1, right? So we just write like this. So you can see this part is the common. Let's put this in the first. Don't forget that here has 1 here, right? We just didn't write it out, right? So here is m plus 1, right? Pretty, I mean, no big challenge for you guys now, right? Same is AW plus 7V. So AW plus 7V. So let's put the AW7V out first. And the W plus 1, right? Here has 1 here. Just didn't write out. Okay, let me save this screen. All right, let's go next. What we goes to? We go to 62. Let's go to the rest 6 from 63. Let me see how much left. 63 to 74, 12 left. Do you think homework is too much or proper amount?
Proper.
Proper, excellent. All right, let's see 63. 63, we'll still do like this way. Or you guys can, let's do a change. We can do this way, all right? These two and these two group. These two, so y is the common one, is 2 plus x, all right? So -8, -4x. So -4, 2 plus x. We'll do different way. A little bit do. We don't first two. We got first and third term is second term and fourth term is a group. So 2 plus x is the common part of y minus 4, right? Actually, if you do first two and second two, that's different group. The same results. There should be no change in the final conclusion, final results. 64, all right, 64 here. Let's do the same. Use these two as group. So you can see is X is the common part and 6 plus Y. And second and two, negative 42 and negative 7Y. So negative 7, 6 plus Y, right? So 6 plus Y, put it first. Take it out first, X minus 7. Same, let's do 65. These two group and these two is a group. They're both negative, both positive, right? So you can see 2x, and here is x squared plus 4. And second one is negative, put a negative out, x squared plus 4, right? So x squared plus 4 is the common part, and the rest, okay, is much easier, right? All right, let's go back here. First two group, first two. So it becomes x squared, right? 2x minus 1. And second is negative 5 and 2x minus 1, right? The 2x minus 1 is the common part, and rest, right? Right, okay, 67. Let's see this one, first two, second two, big group here. So it's 4x, and rest is x minus 2y. Second group is negative 3 is x minus 2y, right? You can distribute it to confirm it. So x minus 2y became a common part. And the rest is 4x minus 3. Right? It's very easy. Right now it's became much easier, right? You can familiar with these kinds of group factoring progress. Actually, is try to find a group first, and then find a greatest common factor. Actually, it's additional step to the greatest common factor, right? So first two, the 5x, so y minus 3. Next one is negative 6, y minus 3, right? So y minus 3, gotta take it out first. Here is 5x minus 6. 69. First group, second group. First group, common is q, right? Q out, 5q minus 4p. Second one is take a negative out, 5q minus 4p. So 5q minus 4p is the common part. So the rest is q minus 1. See 70, same group this one, right? So m is the first, so 6m minus 5n. Second one, take a negative out, 6m minus 5n, right? So you can get a 6m minus 5n, and rest is m minus 1, right? So here, 1 actually here, right? We didn't write out. All right, 71. We also group here 2, 5, 2, 5. They have pattern here. That's easy first, right? So x cubic is the common factor for the first group. So it's 2x minus plus 5. Second group is 2x squared. I missed something here. Oh, no, sorry. So actually here x is the common factor. 2x plus 5, right? So 2x plus 5 is the common part. The rest is what? X cubic plus x. What have we found? These two, they still have common factor, right? So we need to take this out. We can take an additional x out. Take additional x out of here. So the rest is x squared plus 1, right? So we need to do this. Plus 1. Don't forget it here. This can be further factored. So it means what? It means these four terms, they have common factor x. So we need to be careful about this one. So they are not prime to each other. They can be further factor, like 72. This is y. Each one have the common factor at least y. We take a y out first. All right, so the rest is became 4y cubic plus y plus 20y squared plus 5. So right now you can group it in again, right? Okay, so y. So here, maybe here in this, use the bracket. So you can got what? Y, 4y squared plus 1, right? And here plus 5, 4y squared plus 1. Actually, so inside this bracket, actually is can do the group factoring. So y, 4y squared plus 1 is the common part of these two expressions, right? So the rest of y plus 5. So here, even further factoring, because you can see there are 4 terms, they have common factor now. All right, let's see, move down a little bit further. 73. So we still consider two groups here first. All right, so you can see what's the common factor of this one? 6 times 2, 6 times 7. So it's 6, right? 6x squared. The rest is 2y and minus 7. Let's check, double check, make sure. 12x squared y and minus 42x squared, right? So it's correct. And the second group here is at least -2 is the greatest common factor and became 2y minus 7, right? So you can 2y minus 7 is the common part, and the rest is 6x squared minus 2. They can be further factored, right? So we do additional step. Because of this one, 2 is their common factor. So we take the 2 out. All right, so here is 3x squared minus 1. All right, so see, do additional step here. You can see each step actually build on find the greatest common factor, find the group factor, and then continue factor, continue factor. All right, last one, 74. Let's see this group like this, because both negative, both positive, right? All right, so see this one. So 15 is their greatest, right? 6 plus y squared, right? So next one is -3, 6, x is the common factor as well, right? X take it out, 6 plus y squared. So 6 plus y squared is their greatest group factor, common group factor, and the rest is 15 minus 3x. 15 minus 3x can be further factored. We take 3 out, right? 3. And the rest is 5 minus x, right? We further factoring, All right, so we finish the homework part. We review the GCF, greatest common factor for the 2 terms, 3 terms. All right, we also find the group factor. First, we need a group and then find their group factor. Group factor right now, up to now, we only based on the group factor only have 2 terms, binomials, only 2 terms. So homework part is done. So we focus this one a lot. So we need to move a little bit further factor part. So take a 5 minutes break and then we come back to the new topic about the trinomial kinds of factor. Trinomial factor. All right, sounds good. See you a little bit late. 5 minutes break, come back 3:51.